Have you ever had an idea so wild, so crazy, that nobody believed you? Well, hang on. You'll want to hear this story. A scientist had a theory.
Land. Flood. Huge.
I didn't really believe it at first. Well, I was surprised that I hadn't heard about it before. It was kind of weird just to think about that.
The scientist's theory stated that water, a whole lot of water, carved and shaped parts of the Pacific Northwest. He claimed there was a giant flood, bigger than any flood ever seen. The problem was, very few people believed him.
It sounded pretty, unrealistic.
His ideas needed more proof, but he wasn't going to look for more evidence. So somebody else had to. Are you dizzy? Are you confused? Don't worry, we'll clear everything up. I'm Wynn Renz, and I'll be your guide. Together, we'll learn more about
Really big.
Okay, we get the point. It's really, really big floods. The student's story of the Ice Age floods.
Production support for Really, Really Big Floods was provided by the Greater Montana Foundation, the University of Montana, where the discovery continues, and by viewers like you, who are friends of Montana PBS. Thank you.
Way back in 1922, a geologist walked the land in eastern Washington. He noticed strange rock formations. He studied the shape, the texture of the rocks. They were unlike anything he had ever seen. He saw places that looked like a waterfall, except there was no water rushing over the cliffs. He saw a waterfall, but it looked like an even bigger waterfall existed before this one. He kept walking and studying. He ruled out various possibilities and arrived at one unbelievable theory. He believed a giant flood caused this. No, not that kind of flood. Bigger than any flood anyone had ever seen. But he had a problem. He didn't have a source for the water. He proposed a gigantic flood, but couldn't say where the water came from. The geologist's name was J. Harlen Bretz. He was born in 1882 in Michigan. At first he was interested in astronomy, but he thought he wasn't very good at it, so he switched to geology. He became a well-respected scientist who studied the origin, history, and structure of the Earth.
Kind of a bristly, prickly personality. He was quick to differ with you if he didn't agree.
Dave Alt has been studying the Ice Age floods for more than 30 years. He's written a book about it. Some of his college professors worked with Bretz.
So he was like a lot of people we all know, a very smart person who thought things through, came to certain conclusions, and then defended them. We all know people like that. And that was how he was. I mean, I don't think he was especially lovable, but he was a very good person.
In other words, J. Harlen Bretz was hard-headed. Sometimes that was a good thing, and sometimes that was a bad thing. It was a good thing when he ignored other scientists' early criticisms.
I hate to accept a theory which requires a seemingly impossible quantity of water.
Obviously, they were way too close. They just decided to stamp out old Bretz.
Geologist Jim Sheldon has been interested in the Ice Age floods since he was a kid. He believed Bretz presented solid evidence, but a flood that size would require more water than anyone could imagine. Without knowing where that much water came from, the other scientists dismissed everything.
And unfortunately, they decided to do this without looking at his evidence.
Another scientist figured in the story. His name was Joseph T. Pardee. He never worked directly with Bretz, but they would affect each other's lives. Pardee was born in 1871 and grew up in western Montana. He started his career studying Glacial Lake Missoula.
And there is a tradition, which I think is true, that Pardee went around telling his friends back in 1927 that he knew where the water had come from for Bretz's flood, that it had come from Glacial Lake Missoula.
It seemed obvious. Over here, there's a ton of flood evidence. Over there used to be a giant lake. But at the time, Pardee and Bretz had no physical evidence to connect the two. Look, these guys were smart. They knew they needed more than just an idea. In science, you need proof. Let's see if we can connect Glacial Lake Missoula with Bretz's flood. Do you see these lines running across the mountainside? Where did they come from? Before J. Harlen Bretz ever thought of a giant flood, Joseph T. Pardee started examining these clues. Pardee realized these lines were caused by water from an ancient glacial lake. Today you see the city of Missoula, Montana. 15,000 years ago, this valley was all underwater.
I thought it'd be kind of cool if we had all had like little waterproof houses and we could like look around and we'd have these little submarines driving around.
All this water cut into the mountainside. The shorelines help trace an exact outline of the glacial lake. Pardee used the evidence to provide the vital statistics for what was named Glacial Lake Missoula. It covered approximately 2,900 square miles. It held approximately 500 cubic miles of water. That's the same amount as two of the Great Lakes, Lake Ontario and Lake Erie. At its maximum filling, the lake was 2,000 feet deep at the dam and about 950 feet deep in the Missoula Valley. Sometimes it's hard to imagine just how big Glacial Lake Missoula really was. I'll show you its size compared to me. When I get to the top, you can see I'm just a little speck. This mountain is huge, and most of it was underwater. Think about it. A whole city underwater. More than 900 feet deep. Let's look from the other direction. The tops of mountains would have been islands. Here's where I was standing. It leaves you with some big questions.
Well, I kind of wondered how it had actually started and why it wasn't still here.
Let's begin with how it all started. In a geologic investigation of a lake, what is the first thing to look for? Well, nature intends all surface water to run downstream and into the ocean. Therefore, lakes can only exist if something is blocking the flow of that water. So the first question Pardee tried to answer: what kept the water from leaving Glacial Lake Missoula? Pardee and other geologists learned that 12 to 15,000 years ago marked the end of the last ice age. The Cordilleran ice sheet crept south to the current Idaho-Montana border. Pardee traced the glacial lake shorelines in Missoula west to almost the same spot. It's where the present Clark Fork River runs into Lake Pend Oreille. The ice sheet fit across here to block the flow of the Clark Fork River. The giant ice dam was 2,000 feet thick and 30 miles across at its widest point. This huge ice dam forced water to back up into western Montana and form Glacial Lake Missoula. Now wait a minute, I've got a question. A dam made out of ice? Here's ice. Now here comes some water. See, the ice floats. That's no good. Maybe we need some bigger ice. I loaded some ice blocks and took them to a creek. I'm building my own ice dam. My dam diverted some of the water, but it couldn't stop it. Within a few minutes, the dam collapsed. Miniature icebergs raced downstream. Think about it. What went wrong with our ice dam? In the meantime, maybe we need to get smaller instead of bigger. Imagine looking beyond the mountains and seeing a giant wall of ice. It covers hills, dips into canyons, and stops the flow of water. It's all the size of, hey, whose fingers are in there? Okay, so it's just a model. But even in science, you need to use your imagination. That's what Pardee did. We brought in geologist Mindy Mason to help explain how our ice dam model works.
And here in the model, we do have the water backing up. We have a thick piece of ice, and it's buttressed with the cliffs on either side of the Clark Fork River. So the ice is buttressed by these rocks and really conforms to the rocks, so it creates a seal, and the ice went actually down to the lake level, down to the valley floor, so it created a seal. And you had that wherein in our experiment we weren't able to get that in the field because of the flow of the water.
You can see why our dam wouldn't hold the creek water. The ice blocks didn't conform to the land or creek to create a seal. Ice doesn't make a good permanent dam, but it can make a good temporary dam. This is the cool part about science. You find one answer and it opens up 1,000 new questions.
Where the water went? Like, did it just evaporate or something?
This was a popular way of thinking at the time. Most geologists learned landscapes formed very
slowly.
It's a thinking called gradualism, that all the processes in geology are slow and gradual. J. Harlen Bretz studied this in school.
Most people, if they learn something in school, they believe it for the rest of their lives. If you get the question right on the midterm, and if you get an A in the course, you're very likely to go through life believing it. And Bretz was one of those people who didn't do that. That was one of the reasons he achieved as much as he did. You've got to be willing to drop what you've already been taught and take up some new ideas. And most people find that very hard to do.
Bretz opened his mind to new ideas based on the evidence. He knew evidence like these canyon walls, chiseled by fast-moving water, indicated the flood happened suddenly and violently, not slowly and gradually. Bretz didn't care what everyone else was saying. Again, it was a good thing. Bretz and Pardee had one thing in common: vision. Not that kind of vision. They could see the evidence in a different way and then accept a new idea. Let's try that on some of the evidence we've already seen. When some scientists first looked at Glacial Lake Missoula, they proposed a theory that the lake drained slowly and gradually. Let's look again. That's what Joseph T. Pardee did. How could the lake drain quickly? Remember what we learned about ice dams. They don't make good permanent dams. Maybe the ice dam failed. We went back to our model. The signs were all there. Icebergs melting, water level rising, cracks forming. The water was starting to work its way under the ice. We brought geologist Mindy Mason back to show us how an ice dam can fail.
So, two things. It could have created subterranean trenches under the ice, and that would cause failure of the ice, and it would probably create a channel, eventually create a channel from the bottom up, and then the ice would collapse in on itself. The other thing that could happen is that the water would have become so high on the ice dam that actually would flow over the top, and these things may have occurred simultaneously too, and then once the whole thing collapsed or was eaten through with the water, the whole thing failed, and you would lose the main portion of the dam that backed up the water.
When a giant ice dam 2,000 feet thick collapses and all that water comes rushing through, what would it sound like?
Have you ever heard ice come out of a refrigerator? I don't know. If you hear like a big waterfall, like hitting more water, it's just kind of like pouring.
I think that the cracks and pops are probably like deafening.
Crunch, crunch. I don't know what the sound would be.
It's kind of embarrassing, but
I'd be scared.
If the ice dam breaks and releases all that water, what would the water do? We got our hands on some serious water power. The fire department is going to help us experiment. First, we need a little target practice. Knock the table over? That was fun. We made a big mess. But now we're ready for the real experiment. We're going to cut a canyon in this piece of earth. Our powerful water knifes right through the land. You can almost imagine the floodwaters cutting across the Pacific Northwest. Huge amounts of water moving huge amounts of debris. In just 2 minutes, we made a nice big canyon through this hillside. Now let's put this in perspective. We sat down and did the math to convert the numbers. We're comparing water flow rates. For most bodies of water, they are measured in cubic feet per second. Our rate was approximately 1. Compare that to the Clark Fork River. Remember, it was part of the flood. Today, its average flow rate is 2,700. Now Glacial Lake Missoula. Geologists believe when the ice dam broke, the flow rate was just a little bit bigger than ours. They estimate it at 387 million. How about a different comparison? Take the Mississippi River. That's big. Add the Nile River. Add the Amazon River. Stop. Why don't you add every river on the entire planet? When Glacial Lake Missoula emptied, its flow rate was 10 times greater than all the rivers of the world combined. That's big. Shouldn't all that fast-moving water leave some physical evidence? The flood left this kind of evidence. When Glacial Lake Missoula was full, it left that kind of evidence. The lake emptying quickly must have left a clue behind somewhere. Why couldn't somebody find it? Because no one had really looked from the air. It looks totally different from up here. Joseph T. Pardee got an aerial view of Camas Prairie in western Montana. He recognized the giant clue. We went to Camas Prairie to see the evidence for ourselves. Do you see the evidence? I'm not sure I see it. This is so big. Let's look at a smaller example. You've seen these near streams, rivers, lakes, or oceans. When water flows, it moves the sand or sediment on the bottom to form them. You can use their size to determine the speed and depth of water. They're called ripple marks. This river produces ripple marks about this big. Compared to those, these ripple marks are gigantic. That's me on the ripple mark. Watch what happens when I walk on these. Sometimes I disappear. The large ripple marks are 30 feet high and hundreds of feet long. Geologists estimate the water had to be 800 feet deep, moving about 55 miles per hour to create ripple marks this big. Pardee knew only a giant body of water moving extremely fast could form these marks. He did it. Pardee used the physical evidence and his imagination to find the proof, to connect Glacial Lake Missoula to the flood Bretz described.
For some reason, Bretz did not really do anything about it or pick up on this. But Pardee had the whole story pretty well filled out much earlier than the common story, I guess. And he'd related it to Bretz. Why Bretz decided not to use Pardee's evidence for a long, long time, I don't know.
That was a time when being hard-headed was a bad thing. Other geologists were slow to accept the flood theory, but eventually they came out west and looked at the evidence in person. They saw the landscape and realized only a catastrophic flood could shape the land this way. Let's retrace the flood path. When the dam broke, the Glacial Lake Missoula water crashed across Idaho and into eastern Washington. The surging water created these channeled scablands. Remember in the 1920s, J. Harlen Bretz walked this area. He didn't have an aerial view. The floodwaters moved west to what is today called the Dry Falls. Imagine standing here when the water came thundering down the valley and filled it completely. Did you know when the water came over Dry Falls, it made it 5 times bigger than Niagara Falls? 5 times bigger than this? Now that's big. Here's Dry Falls from the air. Imagine all of this being covered by water. Part of the flood headed south to Palouse Falls. When you stand next to them, the falls seem really big. But look at them from the air. They're just a tiny fraction of the flood that carved these canyons. The flood left Washington and